Hello, my dear children. Welcome to the mathematics class. Today we are going to discuss lines and angles. In this chapter, we are going to discuss the concepts of exercise 6.1. Are you ready to listen the class? Right. So in this exercise, in this chapter, lines and angles, and in the exercise 6.1, we are going to discuss these points. Okay, my children, first point is introduction, and second point, angles in our daily life. Third point, basic terms and definitions, and the fourth point, points. And the fifth point, intersecting lines and non-intersecting lines. And fifth point, perpendicular lines. And last point is angles. Okay, my children? Right. Let us start with collinear points. What is meant by collinear points? If three or more than 3 points lie on a line are called as collinear points. Otherwise, the points are called non-collinear points. Observe this figure, my dear children. Here, the points P, Q, R, and S. All these points are lying on the same line. Isn't it or not, my dear children? Yes. Therefore, we can say that the points P, Q, R, and S are collinear points. Understood this point, my dear children? Right. So let us observe the angles in our daily life. See here, if you look around us, we will see angles everywhere. See here, see this fish. See here, the mouth of this fish. It is an angle. Here, observe this tail of this aeroplane. Here, the angle is formed here. Here, the scissors. See here, here an angle is formed. So in our daily life we can we can observe different types of angles in the objects. Okay, my children, understood? Right. Now let us discuss basic terms and definitions. Okay, my children, the first point, line. What is meant by a line? A straight path extending in both directions with no endpoints. The straight path is called straight line. Simply we call it as a line. Okay, my children, see this diagram, see this figure. This figure denotes a straight line or simply a line. Understood this point, my dear children? Right. Now come to the second point, line segment. What is meant by line segment? A part of a line that includes 2 points called end points and all the points between them. See this figure, my dear children? This is a part of the line. This is a line. If you cut somewhere on both sides, then we get this part of that line. Here a line segment has two endpoints, this side and this side, and the points, all the points between these 2 points. Okay, my children, understood this definition of a line segment? Right. Now come to a ray. What is meant by a ray? A part of a line with one endpoint that continues without end in one direction. Observe this figure, my children. You know, rays, X-rays. From a torch, light rays comes. So here one endpoint will be there, and the other direction there is no endpoint. It is called a ray. It is also a part of a line, but with one endpoint. On the other direction, on the other end, there is no endpoint. It moves continuously without an endpoint. Understood this point, my dear children? Right. Now points. Points means an exact point or a location. If you have to locate an exact position like this. Here this is 1 point, this is 1 point, this is 1 point. In a plane, if you want to locate an exact position, an exact location, we use points. Okay, my children. Generally, we denote the points by the capital letters A, B, and C, and so on. Okay, my children. Understood this point? Right. Now come to next point, intersecting lines and non-intersecting lines. Okay, my children, what is meant by intersecting lines? Which lines are said to be intersecting lines? See this figure, my children. Lines that cross each other. See here, this is one line and this is another line. These two lines are crossing at this point. Do you observe this point, my children? Right. Here the two lines are crossing at this point. Then there are four angles formed here. This is one angle, this is another angle, this is another angle. Okay, my children. Right. Now come to the next point, non-intersecting lines. What is meant by non-intersecting lines? Lines that never cross and are always the same distance apart. They are also called parallel lines. Understood this point, my children? Non-intersecting lines are also called parallel lines. Parallel lines or non-intersecting lines means they never cross each other. The distance between these two lines are the same distance. Okay, my children? Understood this point, my children? Right. In our daily life also we can observe non-intersecting lines. Some examples of non-intersecting lines. See here, hardwood floor, opposite sides of windows, desks, etc. Understood this point, my children? Parking slots in parking lot and parallel parking. These lines are non-intersecting lines. We can observe around us. Okay, my children? Understood? Right. Now come to the next point, that is perpendicular lines. What is meant by perpendicular lines? Two lines that intersect to form four right angles. See here, this is one straight line and this is another straight line. They are crossing each other. Then how many angles are formed? Four angles. Previously I told you, if two lines are crossing each other at a point, then four angles will be formed. Here these four angles are right angles. Okay, my children, understood this point? Right. Then the two lines are said to be perpendicular lines. Okay, my children, understood what is meant by perpendicular lines? Right. If you observe the environment around us, we can find examples of perpendicular lines. See here, window panes and street of cities. See here, this is one street and this is another street. In general, the streets are at right angle. They are perpendicular lines. There are some examples of perpendicular lines. Understood this point, my dear children? Right. Now come to angles. In geometry, an angle is the figure formed by sharing a common endpoint called the vertex of the angle. Okay, my children, we have already learnt about an angle. Angle means it is a geometrical figure formed by two rays sharing a common endpoint. What is that endpoint called? Vertex of the angle. And the two rays, what are the two rays called? Arms of the angle or sides of the angle. Do you remember this point, my children? Right. The magnitude of the angle is the amount of rotation that separates the two rays. Okay, my dear children, the amount of rotation is said to be an angle and can be measured by considering the length of the circular arc swept out when one ray is rotated about the vertex to coincide with the other. This is about an angle. If the two rays are there, if first ray is there in a standard position, the amount of rotation that the first ray reaches the second ray, that amount of rotation is said to be an angle. Understood this point, my dear children? Right. These are different types of angles: acute angle, right angle, obtuse angle, straight angle, reflex angle, adjacent angles, linear pair of angles, vertically opposite angles. We are going to discuss all these kinds of angles. Okay, my children? Right. Now come to types of angles. The first type of angle is acute angle. Let us discuss the definition of an acute angle. If the measure of angle is less than 90 degrees and greater than 0 degrees, the angle is known as acute angle. Observe this figure, my dear children. Here, angle MON is the angle. What is the amount of rotation here? What is the angle here? 60 degrees. So, this angle is less than 90 degrees and greater than 0 degrees. So this is an example for an acute angle. Understood this point, my dear children? Right. If you look around us, we can find examples of acute angles. See here, my dear children, scale and this table. The angle between this scale and table is an acute angle. See here, nose. Here, nose of this figure. It is an example for an acute angle. Okay, my dear children. See here the edges. See the sides of this stool is an acute angle. Understood this point, my dear children? Right. Now come to the next type of angle, that is right angle. An angle which measures exactly 90 degrees is called as right angle. Okay, my dear children, understood? The angle which measures exactly 90 degrees is called right angle. Understood this point, my dear children? See, this is an example for a right angle. Okay, my dear children? Right. See these examples, my dear children, for right angle. These are examples of a right angle. See here, this is on a right angle. Here, the angle formed. Here, it is also right angle. Here, the edges form a right angle. Here also in the clock. See here, here also one right angle. See here, table edges. They form a right angle. Chair edges. See here, here also edges of this frame. Okay, my children? Right. These are all some examples of right angles around us. Okay, my children? Right. Now come to the next type of angle, that is obtuse angle. What is meant by an obtuse angle? An angle whose measure is greater than 90 degrees but less than 180 degrees is called an obtuse angle. Okay, my dear children, understood this point? Obtuse angle means the angle whose measure is greater than 90 degrees but less than 180 degrees. Okay, my dear children? Right. These are all some examples of obtuse angle around us. See here, this is an example for an obtuse angle. See here, this angle. Here also this angle. It is an example for an obtuse angle. See here, this edges forms an obtuse angle. Here also, the edges of this table, blackboard table, forms an obtuse angle. Okay, my children. So these are all some examples of obtuse angle. Understood, my children? Right. Now come to the next type of angle, that is straight angle. An angle whose measure is exactly 180 degrees is called a straight angle. Observe this figure, my children. Angle XOY. Here at O, an angle is formed. What is the measure of this angle? 180 degrees. So this angle XOY shown in the above figure is an example for a straight angle. Okay, my dear children, a straight angle is equal to two right angles. Okay, my dear children, understood this point? Right. See these examples of right straight angle. Okay, my children, see here, this is an example for a straight angle. This is also an example for a straight angle. This angle, this is also an example for a straight angle. This is also an example for a straight angle. Okay, my children, the two arms of the angle lie on the same line. Okay, my children, understood this point? Right. Now come to the next point, that is reflex angle. What is meant by a reflex angle? Reflex angle is more than 180 degrees but less than 360 degrees. An angle whose measure is more than 180 degrees but less than 360 degrees. Then the angle is said to be a reflex angle. Observe this figure, my dear children, angle AOB. Here inside this angle is acute angle, but here outside this angle AOB, reflex angle AOB is 360 minus 60, that is 300 degrees. The measure of angle AOB, the reflex angle AOB is 300 degrees. Understood this example, my dear children? Right. Now come to the next type of angle, complementary angle. What is meant by complementary angle? If the sum of measures of any two angles is 90 degrees, then the angles are called as complementary angle. Complementary angle means the sum of any two angles must be equal to 90 degrees. If you observe this figure, angle ABC, what is the measurement of angle ABC? 60 degrees. Okay, my children. Now come to angle RPQ. What is the angle? 30 degrees. Okay, my children. What is the sum of these two angles? 60 plus 30 degrees. What do you get? 90 degrees. So these two angles, angle ABC and angle RPQ, these two angles are said to be complementary angles. Understood this point, my dear children? Right. One angle is said to be complementary angle of the other. Understood this point, my dear children? Right. Now come to the next type of angle, that is a supplementary angle. If the sum of measure of any two angles is 180 degrees, then the angle is known as supplementary angle. This is same as a complementary angle. But in the case of complementary angle, the sum of the two angles must be 190 degrees. Whereas in the case of supplementary angle, the sum of any two angles must be 180 degrees. Observe this figure, my children, angle ABC. Here is 60 degrees and here angle ABC is 120 degrees. What is the sum of these two angles? 60 degrees plus 120 degrees. What will you get here? 180 degrees. Understood this point, my children? The concept of supplementary angle. So this 60 degrees is said to be supplementary angle of 120 degrees. Similarly, this 120 degrees is said to be supplementary angle of 60 degrees. One angle is said to be supplementary angle of the other angle. Understood this point, my children? Right. Now come to the next type of angle, adjacent angle. What is meant by adjacent angle? Two angles are adjacent if they have a common vertex, a common arm, and their non-common arms on different sides of the common arm. See this diagram, my dear children. See, observe this figure. Angle ADB, this is one angle. Angle BDC is another angle. For these two angles, vertex is D, common vertex. Both angles are having the same vertex, common vertex, and BDB is a common arm, common side for these two angles, and the non-common arms, that is DA and DC, non-common arms on different sides of this common arm. Understood this point, my dear children? Angle ADB and angle BDC share a common vertex of D and have a common side of DB. Understood this point, my dear children? Understood this concept of adjacent angle? Right. Now come to the Next point, that is linear pair of angles. Linear pair of angles. This is a combination of supplementary angle and adjacent angle. Okay, my children, angle ACD, angle DCB are linear pair of angles. Observe this figure, my children, angle ACD and angle DCB. If you observe these two angles are adjacent angles because the common vertex is C and CD is a common side, and non-common arms are on other side, on either side of this common side. And moreover, the sum of these two angles is 180 degrees. So this is a combination of supplementary angle and adjacent angle. Understood this point, my dear children? Right. Now come to the next point, that is vertically opposite angles. Vertically opposite angles. See this figure, my dear children. Here the line AB and the line CD are crossing, or they are intersecting at point O. Okay, my dear children, they are intersecting at point O. Then how many angles are formed here at O? Angle AOC is one angle, angle COB is another angle, angle BOD is another angle, angle DOA is another angle. In this case, angle AOD and angle COB, these two angles are said to be vertically opposite angle. Similarly, angle AOC and angle DOB, these two angles are said to be vertically opposite angles. If we observe, the vertically opposite angles are equal. If two lines are intersecting each other at a point, then two pairs of vertically opposite angles are formed. That vertically opposite angles are equal. Isn't it or not, my dear children? Here 145 degrees, here also 145 degrees. So these two vertical angles are vertical opposite angles are equal. Similarly, these two vertically opposite angles are equal. This is a property of vertically opposite angles. Understood this point, my dear children? AB and CD intersect each other. Say that they are at a point. They are intersecting at a point. There are two pairs of vertically opposite angles. Understood this point, my dear children? Right. Now come to the next point, intersecting and non-intersecting lines. What is meant by intersecting and non-intersecting lines? Observe these two figures, my dear children. Here the line PQ and the line RS, they are crossing at a point. So these two lines are said to be intersecting lines. Whereas here the line PQ and line RS does not meet at any point. They do not meet any point. So these two lines are said to be non-intersecting lines. Come to this point, line PQ and RS are known as intersecting line, as both have only one common point. This is a common point for these two lines. The lines which do not have any common point are known as non-intersecting or parallel lines. Understood this point, my dear children? Right. Now come to the axiom 6.1. Axiom 6.1. If a ray stands on a line, then the sum of the two adjacent angles formed by that ray is 180 degrees. This is nothing but an example of linear pair of angles. So this is axiom 6.1. Understood this point, my dear children? Here a ray CD is standing on the line AB. Okay, my dear children. Then these two angles, angle ACD, angle DCB, are adjacent angles, and moreover, the sum of these two angles is 180 degrees. Understood this point, my dear children? This is nothing but linear pair of angles. Okay, my dear children? Right. Now come to axiom 6.2. This is the converse of the axiom 6.1. See this axiom 6.2, my dear children. If the sum of two adjacent angles is 180 degrees, then the non-common arms of the angles form a line. See here, my dear children, the sum of these two angles is 180 degrees, and then they form a linear pair. Now the non-common arms of the angles form a straight line. So here a straight angle is formed. Understood this point, my children? This is converse of the axiom 6.1. Understood this point, my children? Right. Now come to theorem 6.1. Theorem 6.1. If two lines intersect each other, then the vertically opposite angles are equal. I have discussed this point previously when we are discussing about vertically opposite angles. If two lines are intersecting at each other at a point, then vertically opposite angles are equal. This is a statement of the theorem 6.1. Let us prove this theorem. Okay, my children. Given two lines AB and CD intersecting at O. See, AB line and the line CD are intersecting at a point O. Okay, my dear children. Now come to the point. We have to prove that vertically opposite angles are equal. Here we have to show that vertically opposite angles are equal. That is, what are the vertically opposite angles? Angle AOC, angle DOB, or angle BOD. That is, angle AOC is equal to angle BOD. We have to prove this one. Similarly, angle AOD. Observe this figure, my dear children. Angle COB or angle BOC. These two angles are vertically opposite angles. So we have to prove that they are equal. Understood this point, my dear children? Right. Now come to the proof. We are going to prove the two statements, these two statements. On the line AB, see here, observe the figure and observe the steps, my dear children. Here on line CD, by linear pair, this is a linear pair. These two angles are linear pair. Here also, the two angles are forming a linear pair. Angle AOC plus angle BOC is 180 degrees. Isn't it or not, my children? Angle AOC and angle BOC form a linear pair. Means the sum of these two angles is 180 degrees. Similarly, on line CD, by linear pair, angle AOD plus angle AOC, these form a linear pair. So the sum of these two angles is 180 degrees. Understood this point, my children? Right. So by considering the above results as equation 1 and equation 2, we get from equation 1 and equation 2, angle AOC plus angle BOC is equal to angle AOD plus angle AOC, because both are 180 degrees only. That is why we are equating the both quantities. This implies angle BOC is equal to angle AOD. Understood this step, my dear children? Right. Now we are proving that angle BOD is equal to angle AOC. Now on the line AB, here on the line CD, again we use the linear pair definition here. Angle AOD plus angle AOD plus angle BOD is 180 degrees because they are forming a linear pair. Similarly, on the line CD, angle AOD plus angle AOC. These two are forming a linear pair. Let us assume that this result is equation 3 and this result is equation 4. Let us assume that these two results as equation 3 and equation 4 respectively. Okay, my children? Right. From this equation 3 and equation 4, we get angle AOD plus angle BOD is equal to angle AOD plus angle AOC. Isn't it or not, my children? Both are 180 degrees. So we are equating LHS parts. Understood this step, my children? Right. Angle AOD gets cancelled. But then what will you get? Angle BOD is equal to angle AOC. So we have proved vertically opposite angles are equal. Hence, vertically opposite angles are equal. Okay, my children? Remember this result. remember the statement of this theorem 6.1. We use this 6.1 theorem in solving the sums in the exercise 6.1. Okay, my children, right.